Hello everybody and welcome to Blockchain Expert. In this video, I'll be walking you through a project where we'll create a bank account, specifically a bank account that can support joint accounts. What I mean by that is we'll have our traditional bank account functions like depositing and withdrawing. However, we'll make it so that users can create accounts with multiple addresses or multiple owners. Now, this will mean that each owner will have to approve a withdrawal request before you can actually take funds out of the bank account. So kind of emulating, a joint bank account that you might have with roommates or friends or parents or whatever it may be. And this will give us kind of an advanced smart contract that we can write, deploy, test, and then write a very basic front end to interact with. So that's what this project is going to be about, a joint bank account. Going through this, you're going to learn how to use Hardhat. Again, we've talked about that in the past, but this is really going to show you how to use it for a real development project. We're going to test the contracts. You'll learn more about how testing works, and then we'll write a basic front end to interact with the smart contract, and you can go and kind of extend that front end and add more to it afterwards once I show you how to get started with that. All right, so with that said, let's go ahead and get started. Now, I'm inside of Visual Studio Code here, and I've opened up a folder called Bank Account. So you can do this wherever you want, and I'll also note that all of the code that is written in this video will be available to download from a GitHub repository, and there should be a button that allows you to download this as a zip folder as well. So if you ever get stuck, feel free to download that code and reference it. That'll be on the Blockchain Expert website. Anyways, to get started here, go inside of a folder, ideally open up VS Code or some other code editor, and we're going to type the following command to initialize a new NPM repository or a new NPM kind of package or project. So I'm going to type npm init here. You need Node.js for this command to work. I'm going to assume you guys all have that installed. Okay, so I'm just going to run through the defaults here, and yes, that is okay, and we should see a package JSON file pops up. Next, what we're going to do is install Hardhat. So I'm going to say npm install -- save dev, and then this is going to be Hardhat like that. This should install Hardhat for us. All right, so now that we have Hardhat installed, we are going to initialize a Hardhat project by typing npx and then Hardhat like this. That should run us through kind of the project setup. I'm going to create this using JavaScript, and the project root is going to be where I am right now, so I will hit enter. Do I want to add a get ignore? Yes. And we need to install some dependencies. Okay, so here it says you need to install these dependencies. So I'm going to copy this line. I'm going to paste this in here and install those. All right, perfect. So all of that is installed, and now we can actually go and start writing some code. So as you may recall, we're going to put our code inside of the contracts folder. Notice here that it says lock.sol. Let me just zoom in a bit here so you guys can see this easier. What I'm going to do is actually create a new file, and I'm going to call this bankaccount.sol. And I'm going to delete this lock file because we no longer need this in the project. So this is kind of just a template directory, right? That came with, a template for deploying and a template for testing. We'll work off of those later, but for now, we're just going to work on the main contract. Okay, so we're inside of our contracts folder. And the first thing we need to do inside of our bank account contract is write our pragma line. So I'm going to say pragma solidity, and then this is going to be greater than or equal to 0.4.22. and less than or equal to 0.8.17. Now, really, you can put any compiler versions here that you want. This is just what we've been using throughout a lot of the different videos in this course, so I'm going to stick with it here. Next, we need to write our bank account contract. So I'm going to say contract bank account like so. Okay, before I go any further, let me just take a quick pause and walk you through exactly what we need to do and the functionality we're going to have in this contract, and then we'll start coding that out. So recall, this needs to support multiple account owners, so joint bank accounts. So first of all, we're going to need some way to represent an account. And for an account, we're going to have to know the owners of that account, so the addresses that own it, the balance of that account, and then we're going to have to allow people to request making a withdrawal from this account. So I'm going to allow anyone to deposit to the account if they're, say, like the owner of the account, right? However, if they want to request funds, they want to actually take some out, I'm going to make it so that every single user or every single owner needs to approve that withdrawal request. So the main functions here are going to be depositing, requesting a withdrawal, approving a withdrawal, and then actually taking that withdrawal out. And then, of course, we're going to have to create the account as well with the specified number of owners. So that's kind of the main idea here. Now let's start writing out some code. So the first thing I'm going to do here is actually write out all of the events that are going to occur. Once we have the events written, then it will be kind of easy to stub the different functions and start going from there. So the events that we're going to emit here, the first one is going to be deposit. So for deposit, our first topic or parameter here is going to be address. I'm going to make this indexed, and this is going to be the user who made the deposit. Next, I'm going to have a uint value. This is going to be indexed as well, and this is going to be the account ID that they made this deposit to. So at this point, I should mention that every single account is going to have a specific ID. That's how we're going to know what accounts users are owners of, or what account we're depositing funds to, or what account we're withdrawing money from. And the idea here is that users can have multiple accounts, right? They can be a part of multiple joint bank accounts, or maybe an account where it's just them as the owner. So we need a unique ID for all of that. Okay, so we have, let's spell this correctly, a uint indexed account ID, and then we're going to have a uint value, which is the amount they deposited, and a uint timestamp, which is going to be the block timestamp. Perfect. So I think that is all right. After deposit, we're going to have a withdraw request. Now for this, we're going to have address, indexed, and then this is going to be the user who requested the withdrawal. We're going to have the uint, and then this is going to be indexed account ID. And then we are going to have the uint. Again, we'll make this indexed. This will be the withdraw ID. Then we're going to have uint amount. And lastly, a uint timestamp. And I realized I forgot a comma, so let me put that here. Okay, now let's put a semicolon. And I think this should be good. Okay, looks good to me. All right, so I'm just going to save and have that auto-formatted and quickly talk about this withdraw ID. So for every single account, there's going to be multiple withdrawal requests that could be sent, right? Multiple people could be withdrawing funds or attempting to withdraw funds at the same time. So just like we have an ID for every single account, we're going to have an ID for every single individual withdraw. That's why I'm putting a withdraw ID here. All right, now after we have the withdrawal request, we're going to have the withdraw. So this is actually a successful withdrawal after it's been approved and we accept the money. So this again will be a uint that is indexed with the withdraw ID, and then uint, and this will be a timestamp like so. Now I could also put the amount here, but since I have the withdraw ID and I would have previously emitted an event that contains the withdraw ID, I'll be able to find the amount associated with this withdrawal. Okay, next we're going to have an event for creating an account. So I'm going to have event account created. For this, we're going to need to know the owners. So we're going to say address. This is an array of owners. These are all the addresses that own the account. I'm going to have a uint, and this is going to be indexed, and this will be the ID of the account. And then I will have a uint for the timestamp that this was created at. All right, I think that's all for our events. Deposit, withdraw request, withdraw an account created. That looks good to me. Next, we're going to have to create our structs and kind of our data types for storing the information. So the first thing we need here is an account. So I'm going to say struct account. And what do we need to store in an account? Well, we need to know the owners. So I'm going to say address owners like that. This is an array. Then I'm going to say uint balance. We need to know what the balance of the account is. And then lastly, we need to know all of the withdrawal requests. So I'm actually going to make a mapping, and this is going to be from an address, or sorry, not from an address, from a uint to a struct that I've not yet created, which I'm going to call withdraw request like that. And then I will call this withdraw requests. Okay, perfect. Now I've noticed here that we're going to have an event named withdraw request. So I'm going to change this to withdraw requested, because above here, I'm going to make another struct called withdraw request, which is going to represent the information we need about each request to withdraw funds. Okay, so now this should be valid. We should be able to have our uint associated with the withdraw request. These uints, by the way, are going to be the IDs of the withdrawal request. Okay, so inside of our struct here, what do we need? Well, we need to know who actually requested this withdrawal. So we're going to have the user who requested this. We're going to have the amount that they requested to withdraw. And we're going to have the number of approvals, which I'm going to store in this uint variable. Next, I'm going to have a mapping, and this is going to go from an address to a Boolean. And this mapping is going to tell me which owners have approved this withdraw request, right? Because we need to know that. And then lastly, we're going to have a variable, which is a Boolean or a field member, whatever you want to call it, which is a Boolean, which will tell us if this request is fully approved. Okay, so let me discuss kind of why I chose these fields. So obviously we need to know who actually made the request. The reason for that is once it's approved, they're the only person who's going to be able to withdraw the funds. Next, we have the amount. Well, that's obvious. We need to know how much they want to withdraw from the account. And then the approvals. Now, really, we could write this as, say, num approvals. I'm just going to keep it as approvals for right now. This is what we're going to check to determine if the request is fully approved or not, right? Once the approvals is equal to the number of owners, then we know that this request is fully approved. Next, we need to know if owners, have already approved this or not. We're not going to let them approve it again if they've already approved it once. So we need to store that information in this mapping. And then we have this Boolean just to make it easy for us when we actually attempt to do the withdraw to know if this withdraw request is approved or not. Okay, perfect. So we have our withdrawal request and we have our accounts. Now that we have that, we actually need a way to associate IDs, so account IDs and withdraw IDs, with these two structs. So what I'm going to do is make a mapping, and the first mapping is going to be a uint to an account, and this will be our accounts. So just like we've done previously in a lot of the previous videos, we have some mapping, and we have an ID that is associated with a struct, and that's how we'll grab these different structs. Okay, next I'm going to have a mapping, which is going to be an address to a uint array. Now, the uint array here is going to store IDs of the accounts that users own. So I'm going to have user accounts here. Now, the reason for this is each user needs to know which accounts they are an owner of. Because you'll see when we create an account, what will happen is one person will create the account and they can set as many owners as they want to set. So that means that you could be a part of an account even though you didn't create it. Hence, you might not know the ID unless you come back to the contract and ask, hey, what accounts have I been added to? So you'll see how that works in a second, but these will just be all the IDs of accounts this user is an owner of. Okay, now I think that's all we actually need. However, I do want to create two other variables here for kind of creating the IDs for our accounts and for our withdrawals. So I'm going to have uint, and this is going to be the next account ID. And then I'm going to have a uint, and this is going to be the next withdraw ID. Now, every account ID and every withdraw ID will be unique. So every time we make a new withdrawal or make a new account, we're going to increment this value. So then the next account will have an ID that is one larger, or the next withdrawal will have an ID again that is one larger. So now that we've done all of this, we can start kind of stubbing out the different functions that we're going to need. And then I guess we can write some of the modifiers and just go from there and write the smart contract. So the first function we're going to need is the deposit function. Now for the deposit function, we need to know what account we're depositing to. So I'm going to have uint account ID. And again, that's because each user can potentially have multiple accounts, so they need to specify this when they send funds to the contract. Now, this is going to be an external payable function because we need to actually accept funds. And here, we'll write some code, but we won't do that right now. We're just stubbing all the functions. Okay, after we have deposit, we're going to write a function that allows us to create an account. So I'm going to say function create account, and this is going to take in all of the owners of the account. So I'm going to say address, call data, and then I'll actually say other owners. And the reason I'll specify other owners is because the person who calls this function will automatically be an owner of this account. So this is the other owners associated with them, okay? Now this is going to be an external function. And the reason I'm making this external is because I don't expect this to be called from inside of the contract. There's no reason why we would need to call this internally. So to save a little bit of gas, I can make this an external function. And obviously the deposit function, this needs to be external because it is payable. Okay, so that is create account. Next, we'll make a function that allows us to request a withdraw. So I'm going to say request, and I'll actually go with withdrawal. And for this, we're going to need the account ID. So we're going to say uint account ID, and we're going to need to know the uint amount, and this will be external as well. Okay. Now, as well as requesting a withdrawal, we need a function that allows us to approve a withdrawal. So I'll say function approve withdrawal. This will take uint, and this is going to be the account ID. And then this is going to be the uint withdraw ID, because we need to know which withdrawal in the account that we are approving. Okay, this will be external as well. Really, all of these functions we're only calling from outside of the contract. We don't need to call them internally. All right. Next, we are going to have function withdraw. This will actually give you the money once a withdrawal has been approved. So once you approve it, we're going to allow that user to make the withdrawal, so then they can call this function. So for the withdrawal, we're going to have a uint account ID and a uint withdraw ID, so we know which withdrawal we are referencing. And then we will, of course, write the code in there later. And now we have a few getter functions that we're going to write just to make our code a little bit easier to work with from outside of the smart contract and to understand what's going on. So I'm going to say function get balance. This will take a uint account ID. I'll actually make this a public view that returns a uint value. And the reason I'll make it public is so that we can call this to get the balance of an account from within the smart contract. Next, I will have get owners. So I'll have function get owners like this, uint, and then this will be an account ID. This will be a public view that returns an address array. This address array can be inside of memory, and this will tell us what owners are associated with an account. Next, we're going to have a function that gets us the approvals for a withdrawal. So I'm going to say get approvals like this. We're going to take a uint account ID and a uint withdraw ID. This again will be a public view that returns, and this will be a uint value. Again, this is the number of approvals, not who's approved. And then lastly, we're going to have a function called get accounts, and this will be a public view that returns a uint array that represents the IDs of accounts that this user is an owner of. All right, so let me just specify this as memory. And now we have stubbed all of our functions. So just as a note here, this is what I kind of like to do before I start writing any code. I like to stub everything out, write all of my events, write all of my types, and now I have a very clear picture of what it is that I actually need to do, and I can tackle one function at a time going forward. So let's do that. Let's start tackling some functions. And as we do this, we're going to be writing some modifiers because it's likely that a lot of the preconditions we have, we're going to have to reuse for multiple functions. And I'll also kind of explain a few other restrictions we may want to put on some of these functions, like having owners have a maximum numbers of accounts, maximum number of withdrawals, stuff along those lines. Okay. So let's go to the deposit function first. This will probably be one of the simplest functions. And inside of here, what we're going to do is simply say accounts at account ID dot balance is plus equal whatever the value is that was associated with this transaction. Fairly straightforward, just whatever account ID they want to deposit to will allow them to do that. However, the one thing we probably want to check here is that the user who's making this deposit is an owner of the account that they're depositing to. Otherwise, we probably want to revert this and not allow them to do that. So we want to write a modifier here that's going to specify or tell us if they are actually an owner of the account. So we're going to say modifier account owner. To know if you're an owner of an account, we need to know what the account is. So we're going to say uint account ID. And then we will have our underscore. But before we do that, we're going to require that this user is an account owner. Now, to check that, we actually need to loop through all of the owners of this account and see if they're one of these owners, right? We need to use a for loop to do this. So actually, let me get rid of this require statement. And I'm going to say bool is owner is equal to false. And actually, I could just do bool is owner like that. And now I'm going to say for, and I'm going to start looping through all of the owners of the account. So this is going to be address, or sorry, uint IDX. IDX is less than accounts at account ID dot owners dot length. I'm going to say IDX plus plus. And then here inside of the if statement, if I do this correctly, I need to say if accounts, and this is going to be at the account ID dot owners at the IDX, because we're looping through all the owners, is equal to the message dot sender. Then I can say is owner is equal to true, and I can break out of the for loop. And then down here, I can say require is owner. And as my error message, I can say you are not an owner of this account. Okay, so let's walk through this quickly. We have a variable. This is going to tell us if we are the owner or not. This starts out being equal to false. We then loop through all of the different owners in the account that we're checking. For every single one of those owners, we check if they're equal to the message.sender, the person sending the transaction. If they are, okay, then they are one of the owners. So we'll say is owner is equal to true, and we will break out of this loop. Perfect. Now we need to actually use the modifier. So I'm going to tack that on to my deposit function by saying account owner, and then passing my account ID like so. All right, so now that we have written deposit, let's write the create account function. All right, so for create account, we're going to have a few preconditions that we want to check, which we'll do in a second. Now, the first thing is we want to have a limit on the number of owners for a specific account. Now, you can make this limit anything you want. I think I'm going to go with 3 or 4. I'll see how I feel when we start writing that. And I also want to make sure that each owner that's passed here is unique. So for example, the owner of the account or the person sending the transaction doesn't specify themselves in this array, because if they do that, then they're never going to be able to make a withdrawal, because they'll have to kind of approve the withdrawal, but they won't be able to approve the withdrawal because it will say they've already approved it, right? If we need 2 approvals, but there's only 1 real owner, but it's listing that there's 2 owners and they're the same address, we're going to run into an issue. So you'll see what I mean, but that's what we're going to do. We're going to kind of validate all of the owners. We also want to make sure that each owner doesn't own too many other accounts. So we're going to make a limit on it so that each owner can only have a maximum of 3 other accounts. So in total, they can have just 3 accounts with this smart contract. Now, there is potentially some flaws with that, because since other people can add you as an owner to their account, people could kind of sabotage you and make a bunch of accounts with you in them so that you can't create your own account. However, I just will show you this limit because it's interesting to see how you code this, and then if you want to remove it, you can go ahead and do that. Okay, sorry for a lot of talking, but this is a complicated function, so let's go ahead and get started. So let's assume that we have valid owners, which we'll write the modifier for in a second. But I'm going to say address memory owners is equal to a new address, and we're going to say this is other owners dot length plus 1. Now, the reason I'm doing this is that I need to create an array that contains all of my owners. Now, one of the owners is going to be the creator or sender of the transaction. The other ones will be the ones that are part of this array. So what I'll do is create a new array that is 1 slot larger than the size of this array, so I can then add myself, the person who created the transaction, into this array. Okay, so I'm going to say owners, and then this is going to be at other owners.length is equal to message.sender. Now, what this is going to do is make it so that message.sender, which let's just call that me, the person making the transaction, is the last element in the array that contains all of the owners. And then the other 2 elements right now are actually blank. I will add those in once I verify that these owners are correct, that I can actually add them in, that they don't have too many accounts. Okay. Next, what I'm going to do is get the ID that I'm going to be using for my account. So I'm going to say uint ID is equal to the next account ID. Just copy that into a variable. And now I'm going to loop through every single owner, and I'm going to make sure that they don't already have 3 accounts. If they do, then I'm going to not allow them to create another one. So I'm going to say for uint, and then this will be IDX. IDX is less than the owners.length, which is this array that we've just created. Then I will say IDX plus plus. Okay. Now I'm going to say if IDX is less than owners.length minus 1, then I'm going to say owners at IDX is equal to other owners at IDX. Now, what this line is doing, or this block is doing, is copying the owners from this array into the new array that we've just created. We already have ourself in there, hence why we're having this -1 here, so we don't include ourself kind of a second time, and we don't get an index out of bounds exception. We're just copying the other owners into this new owners array. Okay, so we copy them in, and then we're going to say if user accounts at owners at IDX. Now this is going to work, and this isn't going to give us the 0 address because we've just copied the address from other owners into owners. So now we'll have a valid address here, and we'll check this for all of them, including ourself, including message.center. So we're going to say if this dot length is greater than 2, which really means it's equal to 3 or larger, then we are going to revert, and the error is going to be each user can have a max of 3 accounts. Okay, so that's what I was talking about. We're going to go now into user accounts, which is going to contain an array that specifies all of the accounts that this user is an owner of. We're going to check if they are the owner of 3 already. If they are, we're going to revert. Otherwise, we're going to say user accounts, and then this is going to be owners at IDX dot push, and then we're going to push the ID. Okay, perfect. Now, the reason why it's valid for us to do this is that if we revert later on, so let's say that we push the first owner, we push the second owner, or we push this ID for the first owner and for the second owner, and then the last owner does have a maximum number of accounts, then whatever we did here is going to revert, right? Hence the revert keyword. So you might think, oh, you have to do this in a separate for loop, but no, you don't, because revert will revert the transaction state if this is ever called. All right, now that we have done that, we're going to say accounts at ID, which is the ID that we got here, is equal to, or sorry, dot owners is equal to owners. And then we're going to say next account ID plus plus, and we're going to omit that account was created with IDs, or with owners, sorry, with this ID, and with the block dot timestamp. Perfect. Now we have completed the create account function. We just need to write the modifier to validate our owners before we go through this whole process. All right, so just to clarify here, what we actually did with this for loop is we just checked if each user already had a maximum number of accounts or not. If they did, then we didn't allow them to create this new account, at least with one of those people as an owner. We have not yet, though, validated if each address inside of this list is unique and if they have like the appropriate number of owners. So in this case, we're going to limit it so that you can have 4 owners maximum per account. We haven't yet checked that, but we're going to check that inside of a modifier. So I'm going to write another modifier here. I'm going to say modifier valid owners, and this is going to take in a address, and this will be in memory. And actually, we can make this in call data. Call data is fine, and we'll call this owners. Okay. So inside of here, first thing we're going to check is that the number of owners is valid, right? So we're going to say require, and this is going to be owners.length. I'll actually say +1 because this will be the other owners array that we pass, right? And I'll say that this is maximum of 4 owners per account. And that reminds me, I need to say this is less than or equal to 4. Okay, so we'll make sure that they have a max of 4 owners for each account. Now that we do that, we need to make sure that there's no duplicated owners inside of this array. Now, to do that, we need to iterate over this array actually 2 times using a nested for loop to check for duplicates. So I'm going to say for, this is going to be uint idx, or actually we'll go with I. We'll say I is less than the owners.length. We'll say I++. Now we'll say for uint j, say j is less than owners.length, and actually j is going to be equal to I plus 1. And then we're going to say j++, and then we're going to go here, and we're going to say if owners at I is equal to owners at j, then we are going to revert and say no duplicate owners, and let me add my semicolon here. All right, so let's make this owners. And now let's put our underscore. And I think we are good with this modifier. Now, what is wrong here? Am I spelling owners correctly? Oh, I have this L here. Okay, let's get rid of that. All right, so let me just run through what we did. We checked, obviously, that we have the appropriate number of owners. Then we loop through the owners array one time, loop through it a second time. But the reason we're using this second for loop is for every single owner, we need to look forward in the array and see if any of the other elements are equal to this owner. Hence why I'm saying j is equal to I plus 1. Kind of your traditional algorithm style question here for checking for a duplicate. Now we just continue to do that using this nested for loop. If we find a duplicate owner, then we revert. Otherwise, all is good, and we call the original function. Okay, so let's put valid owners here, and let's pass to this other owners. Perfect. All right, so we've now finished deposit and create account. Now we need to write request withdraw. Now we already have one of the modifiers that we need for this function, which is that the person requesting the withdraw for this account is actually the account owner. So I'm going to put that here. I'm going to say, what do we call this? Account owner with 2 C's. And we will pass to this the account ID. Okay, so that's the first modifier. We're going to need another one just to make sure that the balance of this account is sufficient for us to make the withdrawal that we're attempting to do. We can write that one later. Okay, so assuming that all is good here, how do we request a withdrawal? Well, we need an ID, and then we need to fill in the correct fields in our withdrawal request struct and kind of add that into the account struct, right? So let's do this now. We are going to say our uint ID is equal to the next withdraw ID. We're going to say withdraw request, and then we're going to put this in storage. Request is equal to accounts at account ID dot withdraw requests, and then we're going to access at ID. Okay, it might seem a little bit weird what I'm doing, but I'm essentially making a reference to the withdrawal request struct that is going to be stored at whatever this ID is in the mapping withdrawal requests of the account associated with this account ID. I know that's a mouthful, but if we look here at account, we have our mapping. So we have some uint or some ID to a withdrawal request struct. So what I'm doing is accessing that withdrawal request struct based on the account ID, and then I am creating a reference of that and storing that here. So that's why I've put the location as storage, so that anything that I do on this request object is actually going to modify what's inside of this mapping. Hence, it will change what's inside of the account struct. Okay, so now that we've done that and we have access to this object, I'm going to say request.user is equal to my message.sender. I'm going to say request.amount is equal to amount. And I am going to say next withdraw ID plus plus, and then I'm going to emit the event of withdraw requested with the user, which is going to be my message.sender, my account, my ID, my amount, and my block.timestamp. All right. So pretty straightforward. If we go again and just quickly look at this struct, you can see that what we need to specify here is the user and the amount. These 3 values we can leave as the default values, which will be 0. This will be an empty mapping. And then we'll say, of course, that this is not approved, so this will be equal to false. So now we need to write a modifier that's going to tell us if we have sufficient funds to actually make this request, because obviously we can't request more funds than exist in the account at the time that we're trying to make the request. So let's write a modifier here, and let's call this sufficient balance. Now to do that, we're going to need the account ID. So we're going to say uint account ID, and we will also need the amount. Okay, so for this modifier, we can use one simple require statement, and we can say require the accounts at the account ID dot balance is greater than or equal to the amount. And then for our error message, we can say insufficient balance, and then we can call our underlying function. Okay, so now that we have sufficient balance, let's put that on our function here. So sufficient sufficient, and balance like that. And then we'll pass the account ID and the amount. And I think I spelled that correctly. Let me just check here. Yes, looks like I did. Okay. Now that we have created an account and requested the withdrawal, we need to approve the withdrawal, and then of course withdraw and the rest of the functions that we have here. All right, so let's get into approve withdrawal. First, we're going to put the modifier of account owner, because you need to be an owner of this account to approve a withdrawal from it. So I'm going to say account ID. Now, again, let's assume that everything's good and that you can actually do the approval. We'll write the modifier after. So I'm going to say withdraw request storage request is equal to accounts at account ID. And then this is going to be dot withdraws or withdraw requests. And then this is going to be at the withdraw ID. Okay, again, just making a reference so it's easier for us to access this and change the properties. Now I'm going to say request dot approvals plus plus, and I'm going to say request dot owners approved. And then this is going to be at the message dot sender is equal to true. And now I'm going to check if the request is fully approved. So to approve the request, right, what I'm doing is I'm incrementing the number of approvals that we have. Again, I'm assuming that at this point we can actually approve the request. And then I'm going to say, okay, this owner has approved it. Now what I need to check after I do this is if this owner was the last required approval. If that's the case, we need to mark this request as approved. So I'm going to say if request.approvals is equal to accounts at account ID dot owners dot length minus 1. I'll talk about that in a second. Then we're going to say request dot approved is equal to true. Okay. The reason I'm checking is if the number of approvals is equal to the length of owners minus 1 is because the length of owners includes the owner who made this request. Now, whoever makes the request implicitly approves the request. We don't need them to call approve withdrawal when they are the one who made the request. Obviously, they want that to go through. So we only need to check the number of approvals is equal to the number of total owners minus 1. That means that all other owners have approved the request, and then we can mark it as approved. Perfect. Now that we've done this, let's write the modifier that tells us if this user can actually approve the request. So if they are an account owner, that's great, but they may have already approved the request may already be approved. They may be the owner of the request or the person who created the request. In that case, we don't want them to approve it. There's a lot of kind of edge cases, right, that we need to check. So we're going to write a modifier here, and we're going to call this modifier can approve. So say modifier can approve, and what we need here is the account ID and the withdraw ID. All right. Now that we have this, the first thing that we want to check is if this request is already approved or not. If it's already approved, we don't want to let them approve it. There's not any point in doing that. So I'm going to say if not, account ID dot withdraw requests at withdraw ID dot approved. So I'm making sure it is not approved. Otherwise, I will say this request is already approved. Okay, so that's the first thing we need to require. Next thing is that we need to make sure the user sending this, approval is not the person who made the withdrawal request. So I'm going to say require that accounts at account ID dot withdraw requests at withdraw ID dot user does not equal message dot sender. If it does, we'll say you cannot approve this request. Okay. Next, we're going to make sure that the request actually exists, and I'll describe how this works in a second, but let's say if accounts at account ID dot withdraw requests at withdraw ID, very repetitive, dot user does not equal address 0. Then we'll say this request does not exist. Perfect. Now, the reason I'm checking this here is because if the address is 0, right? So if the user is the 0 address, that means we've not yet created this withdrawal request. The reason we know that is as soon as we create it, we're going to mark the user of that request as whoever sent the request, which will never be the 0 address. So if you see the 0 address, we haven't yet created this, and that's kind of what I'm checking here. Okay, great. Next, I'm going to say require, and we're going to make sure you have not already approved this. We're going to say accounts, and actually, let's copy this and just save ourselves a second here. Okay, paste that here. Dot owners approved. This is going to be at message.sender. And if this is not the case, then we're going to say you have already approved this request. Okay, perfect. Then I'm going to put underscore and my semicolon, and now I've written this modifier. So we're checking if it is not already approved, if you are not the person who created it, if this request exists, and then lastly, if you have not already approved it. If that's the case, you can approve. So let's put can approve now on our function. Okay, can approve, count ID, and withdraw ID, and let's spell this correctly. Okay, so approve withdrawal is done. Now we need withdraw. Now to withdraw, we need to check a few things. First, again, you need to be the account owner. So we're going to say account owner and then account ID. You also need to be the withdraw owner. And in fact, now that I think about it, there's no reason we need to check account owner if we're going to be checking if you are the withdraw owner. So we'll actually remove that and we'll just do it with the withdraw owner. We also need to check if this request is already approved before you can withdraw. So we're going to do that using two modifiers, which we'll do in a second. Okay. Now let's assume that you can actually make the withdrawal. First thing that we need to do is make sure that we have sufficient balance to make this withdrawal. So what I can do here, first of all, is get the amount that this withdrawal is for. So I'm going to say uint amount at accounts, account ID, dot withdraw requests at the withdraw ID, dot amount. Now, the reason I need to check the amount here is because when we tried to create the withdrawal request, or when we did create the withdrawal request, we know that at that point in time, we did have sufficient balance. However, since we can have multiple withdrawal requests at the same time, it's possible that other requests have since been approved and money has been withdrawn from the account. And now when we try to process this request, we no longer have sufficient balance. So we need to actually check this twice. Once when we try to do the withdrawal request, and now when we actually try to perform the withdrawal after the request has been approved. Okay, so I'm going to say require that let's actually say accounts at account ID dot balance is greater than or equal to the amount. Otherwise, I'll say insufficient balance. Now, I will mention that I could have made this a modifier, but I think it's fine to leave it as a require statement the way that I have it now, because I do actually need to use this amount variable, so I don't want to have to kind of write it multiple times if I don't need to. Okay, so now that I have that, I'm going to say accounts at account ID dot balance minus equals amount. Remember, it's important that you subtract the balance before you actually send the transaction. And now that I've subtracted the balance, I'm going to delete the withdrawal request, because if I'm processing it, I want to get rid of it. So I'm going to say delete accounts, and then this is going to be at account ID dot withdraw requests. This is going to be at withdraw ID. Now, when I delete this, what actually happens is I just reset all of the values to their default values, right? So if we go and look at our withdraw request struct, we'll see that what we're going to do is clear the user, clear the amount, clear the approvals, clear the owners approved, and clear approved. And what that will mean is if we try to do something with our withdrawal request in the future, say we try to approve it after it's already been approved and we've already withdrawn, then what you'll see is that we won't be able to do that. It will say the request does not exist because we deleted it, which means we reset the user to be the 0 address. So then our modifier no longer allows us to approve that. Okay. Now that we have that, we will actually do our transfer and pay this person. So we're going to say bool sent comma, is equal to payable at message.sender. We're going to use .call, and we're going to call with value amount, and then our empty string. And then we are going to require that this was successful. So I'm going to say require sent. And then I'm going to emit the withdraw event. And this is going to be with withdraw ID and block.timestamp. Okay, so this is all we need to actually perform the withdraw. We require we have a sufficient balance. We then subtract from that balance whatever the amount is we're about to withdraw. We delete our withdrawal request, and then we go here and we actually send the money. Now, again, it's important that we delete this, and one of the reasons it's important that we do this is so we cannot try to withdraw the same withdrawal request multiple times. So now we need to write our modifiers for kind of the precondition checks. So we're going to write the modifier that tells us if we are the withdraw owner. So let's do that first of all. Let's say modifier. And actually, let's just do can withdraw as our modifier. For this, we want to take in a uint account ID and a uint withdraw ID. Okay, so let's do that here. And this needs to be lowercase. My apologies. All right, so first thing we need to check is that we are the owner of this withdraw. So we're going to say require that counts at account ID dot withdraw requests at the withdraw ID dot user is equal to message.sender. Otherwise, we'll say you did not create this request. Okay. Now that we have checked that, we need to make sure that this request is approved. So we're going to say require that accounts. And you know what? Let's just copy this whole thing here. And then dot approved is equal to true. And actually, I don't need to write the equals. I can just write approved like that. And then I will say this request is not approved. Perfect. Now, we could write some additional logic if we want, but this is actually all that we need. And the reason why this is going to disallow us from making the same withdrawal multiple times using the same withdrawal request is, again, because when we delete the withdrawal request, which we do down here, we're going to clear that approved field to be false, and we're not going to be able to approve this request because now the user is equal to the 0 address, so we'll never be able to do the same withdrawal multiple times. All right. Now let's put our modifier here, which is going to say can withdraw. We'll pass our account ID and our withdraw ID like so. Perfect. Now we have some easier functions to write: get balance, get owners, get approvals, and get accounts. If we want to get the balance of an account, then what we can do is actually just steal this right here and say return accounts, account ID dot balance. That reminds me that if I wanted to, I could actually call this get balance function here rather than using this line, but I'm not going to do that. I'll just leave it the way it is. To get the owners of an account, we're going to do a similar thing, except rather than returning the balance, we're going to return the owners. Now, if we want to get the approvals of a withdraw ID, we want to say return accounts at account ID dot withdraw requests at withdraw ID, and this is going to be dot approvals like that. And then lastly, get accounts. We're going to return user accounts at the message dot sender. Okay, so with that said, that completes this very long smart contract. Again, feel free to pause the video, go back if you need any help, or if you got lost at any points, that's completely fine. All of the code will also be available from the GitHub repository, as well as a download link where you can just download the source code. Okay, now that we have this contract completed, what we want to do is test this and make sure that this contract is correct. So for us to be able to test this, we need to go into this test file here, and we need to essentially delete all of the existing tests that are in here. So let's just start by doing that. And we need to write kind of a test suite that will go through and test all of the different functionality, make sure the edge cases are handled correctly, and everything is all good, right? That's what we need to do. Now, I understand we haven't got too much into testing, so I'll kind of go slowly with you for the first few tests. Then I'll go through a bunch of them, and we can go from there. Okay, give me a second. I'm just going to clear some of the code that's in here and some of the comments, and then we'll get started with testing. All right, so I've just cleaned up the code a little bit here, and now we're going to start getting into testing. Now, the first thing we need to do when we are testing is we need to deploy the contract or write some kind of reusable function that allows us to do that. So let's go through kind of step by step. First, I'm going to change this from lock to say bank account. And pretty much everywhere where it says lock, I'm just going to change that to say bank account. So here, go and change this to bank account and make sure this is exactly the name of the contract that you have in the contracts folder. Now here we'll go with capital bank account. We're going to say await, and then this is going to be bank account dot deployed, and then this will be bank account, and we're going to return the bank account. Okay. So let's go through this. So first of all, what is get signers? Well, what get signers is really the different accounts that we can use to sign transactions. Now, the first account that we have here by default is the one that's going to deploy the contract for us, hence why it's marked as owner. Then we have, I believe, 10 other accounts that we can access, and we can do that by writing something like ADDR1, ADDR2, ADDR3, etc., and just continuing to write up to, I believe, 10 accounts in total that we can access when we are using our smart contract. So what I'm going to do here is actually change this. I'll say that's ADDR0, and I'm going to return from this function ADDR0, ADDR1, ADDR2, ADDR3. I'm going to change the name of this function to say deploy, and we're going to call this bank account. Now, there's a lot of different ways to go about setting up your deployments. The first way that we're using here is going to use something known as a fixture. So notice we have this load fixture function. What this function does is take another function that it can call, and it essentially caches whatever the result of this function is. So we don't have to consistently redeploy the contract. We can deploy it once, save what the state of the contract is after that deployment, and then revert back to that state every single time we want to use the contract. You'll see what I mean in a second, but this is a kind of better way than constantly redeploying the contract before every single test case that you want to run. Okay, so we've set up our deployment. All we're doing is we're getting the contract factory. We use bank account that's automatically going to get it from the contracts directory, and then we just await this being deployed. Once it's deployed, then we come here and we can go ahead and return the bank account instance, and then all of the accounts or addresses that we can use to kind of connect to this bank account instance and to this smart contract. All right, now that we have this function written, what we're going to do is write a describe block. Now, what I usually like to do is separate all of the different tests that I want to write into kind of separate describes. So that's what describe allows you to do. You can kind of bulk or block a bunch of tests together that are all under like a subheading, right? So the main heading is bank account. That's a contract we're testing. And then the subheading here, for example, would be like deployment. So all of the tests that I'm going to put inside of this describe block are going to be related to deployment. So for the first test, I'm just going to say it should, and then this is going to be deploy without error. Okay. And then I'm going to put an asynchronous function here. And inside of this asynchronous function, I'm going to say await load fixture and then deploy contract. What I call is deploy bank account. And we're not going to call the deploy bank account. So again, load fixture is going to call this function if it's not been called before, or simply give us these return values without having to recalculate them every single time that this initial function is called. Okay, so this is our first test. We're just essentially deploying the contract, and we just want to make sure this works. If an error occurs, it's automatically going to fail this test. If an error doesn't occur, it's automatically going to pass, so I don't need to write anything else. I can just put it like this. Next, we're going to write another describe, and this is going to be for creating an account. Now, when we create an account, there's many different things that can happen, right? So let's go and have a look at this here. If we go to create account, we can fail valid owners, or we can fail if this account already has multiple other accounts, or this, owner already has multiple other accounts. So there's a lot of different ways that this function can fail, and we essentially want to test every single possible case that we can. So we want to test first, okay, is this successful? Can we create an account with 1 owner, 2 owner, 3 owner, 4 owner, etc.? Then we want to test and make sure it doesn't let us create an account with duplicate owners, doesn't let us create an account with too many owners, doesn't let us create an account where 1 owner already has 3 accounts, etc. Right? Let me just fix this so this says max. So those are kind of all the edge cases we want to go through. And I just realized that we need to change the name of this to say bank account. Okay. So now that we've done that, let's start writing some of these test cases. So first test case, we're going to say it should allow creating a single user account. Okay, and we're going to put an async function. Now, in case you haven't kind of got it at this point, describe is what you're like blocking different test cases into, and then it is one individual test case. So I'm saying it should deploy without error. It should allow creating a single user account. You can kind of write these however you want, but you want to be descriptive in what it is that your test case is doing, and it's easy to organize them when you have these describe blocks. And you can use as many of these as you want and kind of nest them inside of each other. All right, so for this first test case here, what we need to do is say const bank account, and then this is going to be ADDR1 is equal to await load fixture. And for load fixture, we're going to pass the function deploy bank account. Now remember, we're returning bank account ADDR0, 1, 2, 3, and we're actually going to return one more as well, because we're going to need that in a second. So I'm simply grabbing the 2 elements that I actually want, which is, we're going to go with address 0 and bank account. And now that I have the instance of my smart contract, I can use this to try to create an account. So I'm going to say bank account dot connect. I'm going to connect this to address 0. I'm going to put in a wait before this as well. And then I'm going to say dot create account. So when I connect this to an account, that means that I'm going to use this account to send the transaction to this function. And then to this function, I pass as a JavaScript object or JavaScript objects, whatever the required parameters are. So in this case, I want to create an account with just 1 single user. So I'll pass an empty array for the other addresses or the other owners. Okay, so I wait that to happen. Now, after that happens, what I'm going to do is call a function that will tell me what accounts this owner has, so that, or this address has, so I know if this was actually successful or not. So I'm going to say const, and then this will be, let's go, accounts is equal to, and then bank account dot connect ADDR0 dot, and then this is going to be get accounts. And now what I'm going to do is I'm going to say expect accounts dot length dot to, and then, this is going to be dot to dot equal, and then 1. Okay, so this is how you actually make kind of like an assertion. You're checking if something is the case. So I'm expecting this value here to equal 1. And I'll show you a bunch of other matchers you can use. That's what this is referred to. Like these are matchers. You could, for example, do to not equal 1, right? That's another example of one you could do. Okay, so this is test case number 1. Before I get ahead of myself and go any further, I want to show you how we actually test this. So to test this, I'm going to bring up the code here. I'm going to cd into my project. Now, I'm actually already inside of the project, which is bank account, so that's fine. And I'm going to run npx hardhat test. Now, when I do that, it's automatically going to test all of the test files that are inside of my test folder. Okay, so we're getting an error here. And let's see what's happening. It says should deploy without error. Okay, good. And then it says should allow creating a single user account. Expected undefined to equal 1. Okay, so what that means is that I most likely spelt this function wrong or it doesn't exist. So let me have a quick look here and see. Okay, so get accounts does exist. That's fine. For some reason, though, accounts.length is not equal to 0. So let's just quickly console.log our accounts, and let's see what we're actually getting here. Okay, so if we look at the log here, it says promise pending. Okay, so that is the issue. We forgot to say await here. So I'm going to await that request to be sent to the smart contract. Let me just clear this and rerun. And hopefully now this test should be successful. Okay, so there you go. We can see that it's now successful. So this was before a promise that had not yet resolved, hence why this test was failing. Now that I have awaited the result of the promise, it is all good and the test is passing. Okay, so that is test case number 1. Next test case, I'm going to copy this one for, and I'm going to say should allow creating what's called a double user account. All right, so now we want to grab, as well as address 0, address 1. Now remember that since we're continually calling this function, every single test case, we're kind of starting with a fresh contract that does not have the state from the previous contract, or from the previous test, sorry. So whatever happened in this test is not going to affect this test, and that's typically a good thing. You don't want to have your tests failing because other tests before them may have failed, right? Anyways, now that we understand this, let's pass ADDR1 here. And now what I'm going to do is make sure that both address 0 and address 1 have one account in their accounts list. So I'm going to copy this, and we're going to say accounts 1 and accounts 2, and I'm going to say accounts 1.length and accounts 2.length, and for accounts 2, I'm just going to put ADDR1 here. So it is a bit of repetitive code. I could maybe wrap this in a function, but I think for our use case, this is fine. Okay, so now it should allow creating a double user account, so that should work. All right, now that we've done that, let's do another one. Should allow creating a triple user account. Okay, so let's go here to ADDR2. And now we're going to say ADDR2 here. And now again, we're going to do the same thing. And this is going to be accounts 3, and ADDR2. And now let's copy this and let's do it one more time for 4 people. So quad user account. Okay, ADDR3, ADDR3, and then we need one more of these. Okay, counts 4. And now we should have our 4 kind of successful test cases handled. So let's try this and see if this works. All right, so we got an issue here. It said invalid address or ENS name. Not exactly sure why I am getting that. Believe we maybe aren't returning the correct value, or we're passing something incorrectly here. Let me have a quick look here, guys. I'll be right back. All right, so I've found the error. It's a little silly, but this address here, ADDR1, ADDR2, etc., they are signer objects, which means that when we pass them inside of the array here and pass them to create account, we're not passing just an address, we're passing kind of all of the properties of this signer object. So really the way that I need to fix this is I now need to add .address at the end of these. So instead of passing the signer object, I'm passing just the Ethereum addresses for these objects. So that's what I'm going to do, .address, and .address. Okay, so now that we've done that, this should work. So let's clear and rerun and see what we get. And there you go. We can see that we pass all of those tests. Perfect. All right, so now we have passed the successful tests. The next tests that we want to run are kind of the failure tests, right? Where we want the transaction to actually revert. So let's copy this first test case. Let's go down to the bottom. Let's say it should not allow creating an account with duplicate accounts or duplicate owners. Let's say that. Okay. So the way we can test this is we can say ADDR0 dot and then address. And rather than using this kind of expect here, we're actually going to say await expect. We're going to wrap what it is that we're calling, and we're going to say to.b.reverted. So we're going to make sure that this here, so bank account.connect.create is reverted. So that's how you actually check if this fails or not. Okay, easy enough. So that's how we check if this test case fails. Now we're going to do another one, and we're going to make sure that this test case fails if we pass too many owners. So it should not allow creating an account with 4 or with 5 owners. So let's do that. And now we can pass ADDR0, ADDR1.address, ADDR2.address, ADDR3.address, and ADDR4.address. And we need to, of course, import those here. So ADDR1, ADDR2, and ADDR4. And let me just make sure I have 4 accounts here. Yes, I do. Okay, perfect. So those should now fail. And then lastly, we need to make sure that it fails if one of our users already has 3 accounts, right? So the way that we test that is we actually just create 3 accounts for a user and then try to create another one with them. So I've copied in this test case. Okay, let's get rid of this expect here. And rather than having all of these different accounts, let's just take one. Let's write a for loop here. Let's say for, let's go let idx equals 0, idx less than 3, idx plus plus. And then we will say await, and this will be bank account dot connect addr0 dot create account. We can pass just an empty array here. Okay, so we're going to create 3 accounts for this user, which should be successful. Then after we do that, we're going to try to create one more, and we expect that to be reverted. So I'm going to say expect, and then we actually need to put the await before the expect. Make sure you do before, not within the expect, otherwise you'll get an error. And I'm going to say bank account.connect, addr0.create account. And again, with an empty array, I'm going to expect this to be reverted. Okay. Now we should have all of the test cases we need that should be failing. So let's actually run this and make sure this works again. And let's see what we get. Okay, so we actually got one error here. It said should not allow creating an account with duplicate owners. And what this means is that the transaction was not reverted, which actually tells us that we either have an issue with our code or we have an issue with our test case. Now, I actually think that we have an issue with our code, and notice that we have addr0 that's connected, and we pass addr0.address, and that actually allowed us to create an account. Now, that should not be the case, so let's go to bank account, and let's check why that is failing, which is going to be in our modifier, or why this, I guess, is succeeding. All right, so this is our modifier, valid owners, and remember that valid owners is being called with the array of addresses that we are passing to the function. Now, when we do this kind of double for loop here, we actually don't check if any of the addresses that we're looping through are equal to the message.sender, which should not be in this array, right? The kind of creator of the account, the person who sent the transaction, is not in this array. And what that means is that we're not checking if they are duplicated in the array. So the way that we need to fix this is we can just go actually up here, and we can say if, and this is going to be owners at I equals message.sender. Then again, we can just revert and say no duplicate owners. So that should hopefully now fix our problem for us. Again, the issue being we were only looking through the addresses that were passed in the array. We're not comparing them to the person who tried to create the account, so that address could actually exist 2 times, which we don't want. So this should now fix it. And that's exactly why we write test cases. So let's go here now and run this and see if that fixes our problem. And there you go. It looks like that was indeed the fix. Now we have written all of the test cases we need for creating an account. Okay. Now, obviously, this is pretty tedious. There's a lot of test cases we can write. I will continue to write them with you, but of course, feel free to fast forward in the video, download all of the test cases from GitHub, or do whatever you please, but I will continue going through them just so that you understand kind of all of the different matchers and ways that you can write different test cases. So for our next kind of suite of cases here, this is going to be related to depositing, which I have spelled horribly wrong. Okay, that's better. So for depositing, we just need to make sure that when we deposit, the correct balance is reflected in the account, and that we can only deposit to an account that we are an owner of. Okay. Now, since there's going to be a lot of times where we need to have a account already created for us, rather than me constantly kind of creating that account and then trying to do something with it, I'm going to write another function here. So what I'm actually going to do is copy this function here. I'm going to paste this. I'm going to say deploy bank account with accounts. And I'm going to take in here the number of owners, which I'm going to say is equal to 1. I'm going to take in a deposit amount, which I'm going to say by default is equal to 0. And I'm going to say withdrawal amount like this, which I'm going to use in a second, is equal to an empty array. So the idea behind this function is that later, in a bunch of test cases we're going to write, we're not going to want to have to keep repetitively creating new accounts, depositing money in the account, setting up withdrawals. So we're going to write a function that can do this for us, so we can already start with kind of a setup contract and then perform operations on it, which will make our test case simpler. So what I'm going to do here is say const like this is equal to, and I'm going to say await load fixture, and I'm going to load the fixture of deploy bank account. So I'm going to use this existing function to deploy the bank account contract. Now that I've done that, I'm going to create an account with the number of owners specified here that is passed to the function. So I'm going to say const addresses is equal to, and then I'm going to say if owners is equal to 2, then addresses is equal to, and we'll say addr1 dot address. Okay, we'll say else if owners is equal to 3, then addresses equals addr1 dot address and addr2 dot address. And I'll say else if owners is equal to 4, then addresses equals addr1 dot address, addr2 dot address, and addr3 dot address. Okay, now I'm just going to clean up my if statements so they're all kind of in one line here. Okay, that looks good to me. And the reason I'm only going up to 4 is because I know we're going to have a maximum of 4 addresses or 4 owners for an account. Okay, now that I've done that, I'm going to check if the deposit amount is greater than 0. So if deposit is greater than 0, I'm going to say await bank account dot connect. I'm going to connect this to address 0, and I'm going to say dot deposit, and I'm going to deposit 0, and then this is going to be value deposit dot to string. Okay, let me explain this for a second. So when we make a deposit, we need to deposit to an account number. Since I will be creating an account, which actually I realized I forgot to do, so I'm going to do that right here. I'm going to say await bank account dot connect addr0 dot create account, and then I'm going to pass the addresses. Okay, so when I create an account, the first account ID is going to be 0. So if I have a deposit value greater than 0, then I'm going to deposit to account 0, whatever that value is. However, I need to convert this value to a string. It's actually expected that you pass a string value when you are kind of sending Ether here. And this is how you do that when you're calling a function. You do deposit, you pass any of the mandatory arguments, and then as kind of an options field here, so like a JavaScript kind of object, right? JSON object, I pass value, and then whatever the value amount is as a string. And this is going to be in way. So if I had 10, I'd be depositing 10 way, 100, 100 way, etc. Hopefully that makes sense, but that's how you send the value. Okay, so that's what we're doing for deposit. And then I'm going to say lastly, for const withdraw amount, or is this withdrawal amount? Yeah. So const withdrawal amount of withdrawal amounts, I'm going to say await bank account dot connect. I'm going to connect this to addr0, and I'm going to say dot request withdrawal, and then this is going to be 0 and the withdrawal amount. Okay, and then I'm going to return essentially all of this. So let's return that. Perfect. All right, I know this might seem a little bit confusing because we haven't yet used this. We're going to use it in a second. What I'm doing with this line right here in this block is I'm looping through what I'm going to expect is an array of numbers. So like a bunch of values like this. And these are going to be all of the amounts that I want to already have been withdrawn before I start running my test case or requested to withdraw. So I loop through that and I essentially make a request for every single one of those amounts to account 0. And I use address 0 because I know that that is always going to be one of the owners of that account. Okay, apologize if that was a bit confusing, but we just want to set up a reusable function here for the rest of our tests. That is called deploy bank account with accounts. All right, so I'm going to copy this. And we're going to use this now for our first test case of depositing. So I'm going to say it. I'm going to say should allow deposit from account owner. Let's make sure this is an async function. Okay. Now here we're going to say deploy bank account with accounts. I'm just going to grab this and say this is equal to await. I'm going to await that function. For the number of owners, I will have 1. And I actually don't need to pass any of the other arguments here because they are already kind of defaulted, right? 1, 0, array. All right, now we're back down here. And now we want to make a deposit. So if I want to make a deposit, the way that I do that is I say, this is going to be actually await expect bank account dot connect ADR0 dot deposit. I want to deposit into account 0. And the value I want to deposit is going to be, let's see, how much do we want to deposit? Let's go with 100. Okay. Now, what I want to check here is that the Ethereum balance of the contract and my account changed when this function was run. So the way I check that is I say .to change ether balances. So what this matcher is going to do is it's going to check that the Ethereum balance of multiple accounts changed by whatever value we pass. So what I'm going to specify here is bank account and ADR0. And then I'm going to say that I want the balance of the bank account contract to have gone up by 100 and the balance of my account ADR0 to have been decreased by 100. So when I specify this, they're kind of matching up, right? 100 bank account, negative 100 ADR0. And this is going to tell me if those balances were changed by running this smart contract function. So that's how this works. Hopefully that's clear. Yeah, that's what we want. Okay, now that we've done that, I'm going to copy this. And I'm going to say should not allow deposit from non-account owner. I'm going to put ADR1 here. ADR1. Let's get rid of this. I'm going to say to be reverted. Perfect. All right, so let's run our code and see if this works. Okay, let's see. And there we go. So now all of our test cases are passing. So now we know how to create an account. We know how to deposit. Now we need to request withdrawals. We need to actually withdraw. And then we can call, I guess, some of our getter functions if we want to test that out, and all should be good. All right, so I'm going to make another describe here. I'm going to say describe withdraw. And then I'm going to put a function here. And inside of here, I'm going to do another describe. In fact, I'm going to do 2 of them. The first one is going to be request a withdraw. Okay. The next is going to be approve a withdraw. And then the last is going to be actually making the withdrawal. So we're going to say describe make withdraw. Okay, so now we have kind of the 3 subheadings to this subheading, and let's start with requesting a withdrawal. So the first thing that I want to check here is that a user who is an account owner can make a request to withdraw. So I'm going to say account owner can request withdraw. Now this is where that helper function is going to come in for us. So let's kind of copy this again. So what I want to do is I want to deploy a bank account that has 1 owner, that's fine, and that has a balance of 100. So we want 100 to be deposited. Okay, so account owner can request withdraw. Now we are going to call our function. So we're going to say await bank account dot connect ADR0, which is the account owner, dot, and this is going to be request withdraw. For the withdrawal, we want to request from account 0, and the amount we want to request is 100. Okay, so we want that to be successful. And in fact, we don't actually need to write any expects here. We can just leave it as is, because if this transaction is reverted, then this test case will automatically fail. So this is actually valid as a test case. We can just write that. Next, I'm going to say account owner can not request withdraw with invalid amount. Now we're going to try doing this with 100, and we're going to expect that this fails. So I'm going to say expect bank account.connect.to be reverted. Okay. And now we need to write a few other ones where we can't request a withdraw if we are, say, not the account owner. So let's copy this in. I'm going to say non-account owner cannot request withdraw. Okay, so let's take in ADR1. Let's connect ADR1. Let's pass a valid balance of, say, 90. But again, we want to expect this to fail because we are not one of the account owners. So to be reverted. And notice that there's some more kind of matches you can use here, but we only care if it's reverted. We don't really care the reason why. And lastly here, we want to check that we can actually make multiple withdrawals. Again, kind of an edge case, we want to make sure that one user can do multiple withdrawals at the same time. So the way we do that is let's change this now to ADR0. ADR0, okay, let's do the first one for 90, that's fine. We don't want this to be reverted, so let's get rid of that. We don't actually need an expect statement at all. And let's paste this again after we have our await keyword. And let's make sure that they can do 2 withdrawals in a row. Perfect, so I think that should be it for requesting a withdrawal. Let's run our code and see if this works. Okay, so we got an error here. It says bank account request withdraw is not a function. Okay, let's see what I called that function then if that is not the name. Going down here, request withdrawal. Okay, so that's the issue. Let's just fix that. Request withdrawal, 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 withdrawal. Okay, let's run it now and see if this is all good. And we got an error. Account owner can request withdraw. Okay, so it's saying that this failed. So let's see why that failed. Okay, here, oh, well, that is not request withdrawal. That is request withdrawal. Okay, let's run it one more time. And it should be good now. Let's see. And there we go. We pass all of our test cases. Perfect. Okay, now that we have requested a withdraw, let's approve a withdrawal. All right, so for our first test case here, we're going to say should allow account owner to approve withdraw. Let's make this an async function and go from here. I'm just going to copy this line. So let's have a bank account. This time, let's have 2 owners. We can have 100 deposited, that's fine. And then let's have a withdrawal amount of 100. So remember, this is going to actually request a withdrawal for us. So we'll already have one set up. And then all we have to do in here is test the approval. Okay. So inside of here, let's say await bank account dot connect. I actually want to connect to ADR1 because that is not the creator of the withdrawal. Remember, account 0 is going to be creating that. And then I'm going to say dot approve withdrawal. And I'm going to approve withdrawal 00, so account 0 withdrawal number 0, because that'll be the first withdrawal created. And then we're going to say expect, and I'm going to say await. Notice this time that I am putting the await inside, not outside. When I am awaiting if something's reverted or not, I put it outside. When I'm awaiting the value of something, which is what I'm going to do here, I put it inside. So I'm saying expect await. And then bank account dot connect ADR1 dot, and we're going to say get approvals. We want to get approvals of 00. We want to expect that to equal 1. So after this, to make sure that works, we're just going to call the get approval function, and that should return to us 1. And I can actually remove the connect here, since this will work no matter if we are an owner of the account or not. Okay, so that should allow us to approve a single, approval, or single withdrawal request, sorry. Let's copy this, paste this, and now let's do some of the cases where we can't approve. So should not allow account. So should not allow non-account owner to approve withdrawal. So now we just take in ADR2, which will not be one of the 2 owners of this account. Connect to that. And we'll expect this to be reverted. Say await, expect, and then .2 dot, if we can type this properly, .b reverted. Okay, looks good to me. Let's copy this. Let's make sure the same user cannot approve the request multiple times. Should not allow owner to approve withdrawal multiple times. Okay, so we can connect this one. And actually, let me just copy this. And for the first time, we won't expect it to be reverted, but the second time we try to approve it, we will expect it to be reverted. So that makes sense to me. Okay, let's make this ADDR1. And then lastly, we want to make sure the person who made the request cannot approve that request. So we're going to say should not allow creator of request to approve request. Now we know the creator is ADDR0. So let's take this, replace this with ADDR0, and now we should be all good. Okay, hopefully this is clear, but again, we're setting it up so that we have two owners. We have 100 deposited. We make a withdrawal request for 100. We successfully approve it here, and then for the rest of the test cases, we should not be able to approve it, hence why we're expecting these transactions to be reverted. All right, so let's run our code. Okay, and we got an issue. It says assignment to constant variable. So I believe that issue is actually going to be coming from inside of our function, which just means I made a mistake here. So I believe we need to say that this is let. So let addresses, because we are changing addresses here when we have multiple owners. That looks like that was the case. So let's go here and run it and see if that fixed our problem. Okay, there we go. So we requested a withdrawal, approved a withdrawal, all looks good. Now that we have done that, let's try to actually make a withdrawal. So once it's approved, can we actually make it? All right, so I'm going to copy one of these test cases here. I'm going to paste this in, and we're going to start with the successful one. So should allow creator of request to withdraw approved request. Okay, so 100, 100. Okay, looks good to me. Now we're going to take an ADDR0 and ADDR1. Now what we're going to do is make it so that ADDR1 approves the request, because we need that to happen first before we can actually make the withdrawal. So we do that. We're going to say actually await, because that should be successful. And then we are going to say await, expect, bank account, .connect, ADDR0, .withdraw. We're going to withdraw 00, so account 0, withdraw request number 0. And then this is going to be, actually, I think that's all we need for that. And we're going to say .to .change ether balances, because now when we make the withdrawal successfully, we want to make sure the money is actually transferred to this user. And for our balances, we're going to say bank account, and we are going to say ADDR0, and then we're going to say minus 100 and plus 100, which is the amount of the withdrawal request. Okay, so that should be successful. Let's copy that and paste. And now let's actually do the same thing, but let's make it so that we ensure we cannot withdraw the same, the same request multiple times. So I'm going to change the balance or the deposit to be 200. I'm going to make a withdrawal request of 100. And I'm going to say should not allow creator of request to withdraw approved request twice. So we are going to keep our first withdrawal here, which should change the ether balances. So I can actually leave that as is. And I'm going to paste another one here, except rather than to change ether balances, this should be reverted, right? So once we've done this once, we'll try it again and we'll expect that that should fail. The reason I put this to 200, by the way, is just so that it's not going to fail since we don't have sufficient balance. It's going to fail because we already did this request, right? We already withdrew this withdrawal request. All right, so now that we've done that, we have a few other test cases to write. So let's copy this. We're going to say should not allow non-creator of request to withdraw approved request. Okay, so we can get rid of this. We can connect this to ADDR1, and we can expect that that is going to be reverted and get rid of ADDR0 here. That looks good to me. And then lastly, we want to make sure you cannot withdraw a non-approved request. So I'm not going to approve this. I'm going to change this now to be the creator, which is ADDR0. And I'm going to make sure that you do not withdraw that. Okay, so let's give this a shot here. and see if this works. And then we should be done with our testing. So let me pull this up and let's run. And let's see if we pass all of these, and we got an issue. Okay, so it says invalid big number string. Okay, let me see what this issue is, and I'll be right back. All right, so the issue here is that I had plus 100. I can't have the plus, it just has to be 100. Hence why I was getting that issue with the error, or with the number, sorry. So let me rerun this, and let's see now if that's fixed. All right, and looks good. We are now passing all of our tests. All right, so I know that was a lot of testing. Apologize for all of that coding kind of at once here, but I wanted to show you guys how you do kind of comprehensive testing of a smart contract. Hopefully you found that helpful. Now that we've done that, it's time to actually write a basic front end for our contract, look at how to deploy the contract to our local network and how to interact with it, and then we will be finished with this project. All right, so the first thing we actually need to do before we can write our front end is we need to write our deploy script for deploying our smart contract. So I'm just going to get rid of some of the stuff that we don't need. In fact, let's just scrap everything in this main function. We can start from scratch. Okay, so first thing I'm going to do is declare my bank account contract. So I'm going to say const bank account is equal to await HRE dot ethers dot get contract factory, and we are going to get bank account. Okay, next I'm going to say const bank account is equal to await, and then this is going to be bank account dot deploy. And just a note here, if you wanted to pass any constructor arguments, this is where you would pass them, right here. Okay, next I'm going to say await bank account dot deployed. I know this seems a bit weird, but we deploy it, okay? And then we need to actually wait for it to fully be deployed before we can start using it. And then I'm going to write kind of a helper function here that's going to write out the ABI for our contract, right? So we actually get that interface, and it's easier for us to interact with the contract rather than having to manually write it ourselves. So I'm going to say async function write deployment info like this, and then I'm going to say contract, and here I'm going to say const data is equal to this, and I'm going to say contract, I'm going to say the address is the contract dot address, I'm going to say the signer address is the contract dot signer dot address, which is the account address that deployed this. Then I'm going to say the ABI is equal to the contract dot interface dot format, and that will give us a formatted ABI that is nice and easy for us to use. Okay, so that is our data. Then I'm going to say my const content is equal to JSON dot stringify my data null and 2. Don't worry too much about this, but I'm essentially passing 2 here so that I can get 2 spaces for my indentation level for my content. And then I'm going to say await fs dot, and then this is going to be write file. And I'm going to write the file to deployment dot JSON. What I'm going to write is content, and then my encoding is going to be UTF-8. All right. Then up here, I'm now going to await my write deployment info. I'm going to pass to this my bank account. And up here, I'm going to say const fs is equal to require. And I'm going to require fs / promises, which should already be installed. Okay. What this helper function is going to do is write our contract information to a JSON file so that when we actually want to interact with it, it's very easy to do that. And I'll show you now actually how we run this deployment script, because what the flow is going to be is run our deployment script, then we're going to run our front end where we can then interact with the smart contract once it's deployed on our network. So as you may recall from the hard hat lesson, the first thing we need to do is run a local hard hat node. Now this node is really going to act as our blockchain network. So I'm going to say npx hard hat node. That's going to run, let's say, a node instance here on the left side. And notice it gives us a bunch of accounts, private keys, all this kind of stuff. Okay, now I'm going to split my terminal. And on the right side, I'm going to say npx hard hat run dash dash network localhost, and then I'm going to say scripts slash deploy .js. And I think I might have to do ./scripts. Now this is where our deploy script is. So that's a script I'm running, and I'm saying I want to run this on the localhost network. Okay, let me click enter here, and let's see if this works. And there we go. So notice that you can see the contract was deployed here. And then if I look, I have a deployment.json file where I get my address, my signer address, and my ABI, making it so I no longer have to manually write this out. Perfect. Now that we've done that, let's start writing the front end. So I'm going to make a new folder called front end. Inside of here, I'm going to make my base.html, and I'm going to make my script.js. Now in Visual Studio Code, I have a fancy extension that lets me get kind of a boilerplate HTML template. You get that by writing HTML:5 and then hitting enter. And a lot of the stuff I show here is going to be repetitive from the interacting with smart contracts section. So if you haven't yet seen that, then please go watch through that section, because some of this may not make sense until you see that. All right, so here I'm going to make the title bank account test. Now I'll just mention that I'm not going to write a full-fledged kind of front end here. I'm just going to write a basic one that's going to kind of show you how you could write a more advanced front end. And then I'll let you guys go ahead and kind of modify this and make it larger if you wanted to do that. Okay, so I'm going to set up a div here. And in this div, I'm going to have an h3, and I'm just going to say create account. And I'm going to make a way to specify all of the addresses of the accounts that you want to kind of include as owners, right? So to do this, I'm going to put an input field, and I'm going to say input type is equal to text. And I need an ID for this so I can reference it from JavaScript. And I'm going to say actually that this is owners. Okay. Then I'm going to say button, and here I will say create, and on click, I will call a JavaScript function, which I will define in a minute, called create account. Perfect. Okay, so that's div 1. For div 2, I'm going to say, what should we do here? View accounts. I'm going to put a div here. Don't want to put a div. I'm wondering what I want to put here. You know what? Let's actually do a p tag, and let's say ID is equal to accounts. And this is where I'm going to kind of plug in the accounts that are associated with this user. Now for this button here, I'm going to say view accounts. I'm going to call this view. Now lastly, I'm going to put another div here. I'm going to say ID is equal to events. And I'm going to show you how we can listen for events and log those events kind of as they're happening. And then lastly, I need to include the ethers.js script here. Now, you can get this from the ethers.js website. You also can just reference the interacting with smart contracts section in this course. It shows you kind of how you get the script tag. I'm not going to go through that again. And then lastly, I'm going to write a script tag that references my script file that I've created here. So I'm going to say this is text/JavaScript, and src is equal to, this is going to be script.js. And that's actually going to conclude the HTML aspect of our code. Now that we have that, let's go to script.js, and let's kind of define what we need inside of here. Okay, so the first thing we actually need here is our provider. So I'm going to say my const provider is equal to my new ethers.providers.web3provider. And then this is going to be window.metamask. And I forget if it's with capital, or sorry, not windows.metamask, windows.ethereum. I think that's what it is. Okay. And now that we do that, I want to define the ABI of my contract. So I'm going to say const ABI is equal to ABI. I'm going to go to deployment.json, and I'm going to copy all of this and paste that for my ABI, saving us a significant amount of time. Then I'm going to say const address. This is going to be our contract address. Same thing, go to deployment here and let me copy this in. Okay. Now that we have that, I'm going to say let contract equal null. This is where we're going to store actually the contract instance, but we can only do that once we kind of get access to MetaMask from the client. So I'm going to say async function get access. And first I'm going to say if we already have a contract instance, that means we have access already. So I'll just return. Otherwise, I'm going to say await provider.send, and I'm going to send eth_request accounts like that. And for accounts, I'm just going to pass an empty array here. Now next, for my signer, I'm going to say const signer is equal to provider.get signer like so. And then I'm going to create my contract. So I'm going to say contract is equal to new ethers.contract. To initialize our contract, we need the address, we need the ABI, and we need the signer. Again, all of this is covered in the interacting with smart contracts section in case you are a bit confused. And now we have set up our access. Now what I'm going to do is make a very small kind of piece of code here that's essentially going to log any events that occur on our contract. Well, log a specific event, just to show you kind of how you do this. So I'm going to say const event log is equal to document.get element by ID. This is events, and this is where I'm going to write all of the events that occur. Then I'm going to say contract.on. This is how you listen for an event. I'm going to say account created like so. And what I'm going to grab is the arguments of this event. So I'm going to say owners, ID, and then event, which is something we don't actually need to use, but I'll put it here anyways. And then what I can do is whenever an event comes in, I can say event log dot append, and I can append the following text, account create. Now, by the way, this is actually adding this onto the document. Like I'm writing this text onto the HTML document. So I'm going to say account created, and we'll say ID is equal to ID. Now to do this, I'm going to switch out my quotes for backticks so I can embed my variables directly inside the string. And then I'm going to say owners is equal to, and then we will say owners like that. And I think that's all we need for get access. All right, so now that we have the get access function, I'm going to write my get accounts function and my create accounts function. So for get accounts, I am going to say get access. I'm going to await this function. And notice that if we already have access, it'll just return, right? But if we don't, then I need to get access. So that's what I'm doing first. Okay, so await get access. I'm going to say const result is equal to await contract dot get accounts. Okay, and I'm going to say document dot get element by ID. And I got to look at what I called this. I called this accounts. Okay, so we'll put accounts here. Dot inner HTML is equal to the result. Okay, so that's how we get accounts. And actually, this is, I believe, view accounts. So we'll change it to the correct name. And then we have another one for create account here. Okay, so for create account, same thing. We want to get access. And then we want to actually grab all of the account owners. So I'm going to do this. I'm going to say const owners is equal to document.get element by ID. I'm going to get the owner's ID, and then I'm going to say dot inner text dot split at a comma. The reason I'm going to split at a comma is I'm going to expect that they pass in comma separated values. And I'll show you a fancy JavaScript trick to get rid of any empty strings in our array here. Is to use dot filter and to just filter out objects like this. So I'm going to say n like that, and then I'm going to say await contract dot create account. I'm going to pass the owners. I'm going to say dot then, and then I'm going to alert success. Okay, I know I went quickly here, but this is what we need to create account, view accounts, and to get our access. So when we create account, we get our access. Then we go and we look at the owners field, which is an input field. We're expecting comma separated values for the different kind of owners of the account. We grab those, pass those to create account. And then once that is complete, we kind of log to the screen with an alert statement. Yes, this was successful. Okay, let's give this a shot and see if this works. Now remember that when we run this code, we need to use our live server. So I have go live here. Again, in the interacting with smart contract section, I show you that in VS Code, you can install the extension called live server. So you can actually run this. So I'm going to live server my HTML. Let's get that up and running. Okay, and now I have my document. Now let's go to inspect here and go to console. And let's see if we get any errors. Requires not defined, cannot load resource. Let's see, what is the issue with script? Okay, ethers equals require hard hat. I can get rid of that in script.js. Okay, so let's get rid of that. Go back here and refresh. Okay, that looks better. Now, let's start by viewing accounts. When I do that, it's going to pop open MetaMask and connect to the hard hat network. Let me wait for that to finish, then I'll be right back. All right, so I've connected to hard hat. Now, again, remember from the hard hat video that to get your accounts here in MetaMask, you go to VS Code. You go here and you grab the private keys and import those into MetaMask. I'm not going to show you how to do that again, but if you want, just grab account 0, account 1, whatever one you want, grab the private key, put that into MetaMask. Okay, so let's see what accounts I have. I have, if I could, it's kind of small here, it's hard to see, but okay, I have this account and account 5 that both have hard hat Ethereum. Now, just to kind of make sure I don't run into any errors here, I'm going to go to settings and I'm just going to reset the account. If you get any errors with MetaMask, just reset your accounts and it should fix them. It doesn't actually like do anything. It's not going to delete any of your Ethereum or anything like that. It just essentially resets MetaMask and clears some of the transactions. You'll get that issue if you're constantly like restarting the kind of dev server. So that's why I'm doing that. Anyways, I'm going to grab this address. I'm going to grab the address from actually this account. I'm going to go back to account 3. And now I'm going to click view accounts. Okay, when I do that, I'm not getting any errors, but nothing's popping up on the screen. Let me have a look at why that's the case. It's possible that I named this function incorrectly. So view accounts. Okay, let's go here. View accounts. Okay, that seems right to me. Now, document.innerHTML is equal to result. I guess there is no result, and so it's not showing us anything in the inner HTML. Let me just console.log the result here and see if that's going to give us anything. Okay, so go here, refresh, view accounts, and okay, it's giving us an empty array. Fine, that's as we expect. All right, now let's create an account. So for our account, I'm going to paste in the address of the other account. Okay, I'm going to click create, and there we go, MetaMask pops up. Now it's saying we're sending a transaction. Do we want to confirm this? Yes, I do. So I'm going to confirm and success. Okay, so now we're going to have to wait a second, but if I wait and hit view accounts, now notice that I get account 0. Now I can actually create another account, and there you go. Okay, account created just popped in here as one of the events that occurred on the smart contract. So let me actually create another one here. Okay, so create account. Let's confirm this and success. Okay, and there you go. Another account pops in. And the only thing is that it looks like the owners are not necessarily correct here. It looks like it's not actually grabbing the owner that I passed. So let me have a look at that issue. So we say get element by ID owners.inner text. Let me go here. Is this called owners? It is called owners. Okay. So owners, let's see if we can console.log owners. And let's see what we get when we actually call this now. So I'm going to paste this in. Create. Okay, and it gave us an empty array, which is not what we were expecting. So it's apparently not giving us correctly what the owners are. Let me have a look here, guys, and I'll be right back. All right, so I found the issue here. This is kind of a silly issue, but I need to call this .value, not .innerHTML. Value will actually give us the value of the input field. Just silly HTML mistake there. Okay, so let's refresh, paste in our address, and now let's hit create. And now notice that we have an address. Okay, perfect. So now I'm going to confirm this. Success. And we should see that another kind of log comes in here in 1 second, telling us that we created an account. And this time we should have multiple owners. Okay, let's see. All right, 01. Okay, give it a second here to actually be created, and there you go. We can see that we now have our 3 values here, so 0, 1, and 2, and the log just came in, owners equals, and then we have our 2 owners. They're kind of squished together, but you get the point. All right, so with that said, that is going to wrap up this project. Obviously, I could go a lot further with the front end in terms of approving requests, sending requests, or approving withdrawals, accepting withdrawals. You get the idea, but I'm going to leave that to you because at this point, you now know how to do that. I've showed you how to set everything up in terms of kind of the script, how to test all of the functions, how to write the smart contract, how to deploy the smart contract. And really all you have to do is just write kind of the front end triggers, which I will leave to you to write in any of your kind of desired front end frameworks. As a quick recap here, when you are doing this, make sure that you have your node running on the left-hand side. That's npx hard hat node. That's going to run a localhost node for you. Then you need to run the deploy script. And once you run the deploy script, then you can boot up some kind of front end and start interacting with that smart contract. If you shut down this node, you will need to rerun the deploy script, and any contract state is going to be reverted, right? It's going to go back to the original state of the contract. So just keep that in mind. Anyways, I hope you guys enjoyed this project. I hope you learned a lot. As always, the code will be available on Blockchain Expert. I look forward to seeing you in another Blockchain Expert video.